Welcome back, students. Today we're going to continue working with equations of lines. So last lesson we studied how to write equations of lines in slope-intercept form. So just a reminder, your slope-intercept form is y equals mx plus b. So you needed to know what the slope of the line was as well as the y-intercept and plug in those two values, and there you had your equation of the line. Point slope form is similar, except for instead of using the y-intercept, it uses any point on the line. So how it works is it's y minus y1 equals m parentheses x minus x1. You're going to replace m with your slope, but then you're going to replace the x1 with the x-coordinate of the point that you're using, and you're going to replace the y1 with the y-coordinate of the point that you are using. So if you get stuck, if you pull up the notes from today, you can see these instructions and it gives you step-by-step instructions. Rather than reading those, I'm going to go ahead and use those instructions to help me solve the first problem, which when I say solve, what I really mean is just writing the equations of these lines. So for this first line, it says write an equation in point slope form and slope intercept form that goes through, this is my ordered pair, and has a slope of 3. So first thing is I'm going to write down that the slope is 3. If we're graphing, we'll write the slope as a fraction. But if we're not graphing, we'll try to keep it as an integer if we can. So the slope is 3. The coordinate, what is the coordinate that I was given? And that ordered pair is 1, comma, -4. All right, so remember, this slope is my m, and this coordinate, my ordered pair, is x1, y1. So here I have a formula. So what I can do is when you're using a formula, you can do what's called erase replace. So write the formula down, y minus y1 equals m parentheses x minus x1. So what I'm going to do is I'm going to erase the m gets replaced with a value. And in this case, my m, I said, was 3. So I'm going to erase and replace the m with positive 3. The next variable in this formula that gets replaced is x1. So I'm going to erase x1, and I'm going to replace it with what I labeled as x1, which was 1. And then the last variable that gets replaced in the formula is y1. So I'm going to erase it and replace it with what I labeled as y1, which is -4. So I'm almost finished with this, is if I write it in point slope form. The only thing that I don't like is the double negative. All right, so I will not give you homework over this lesson. It means that I really am going to give you homework. A double negative means that it's a positive. Same thing in math. So this is really going to be y plus 4 equals, and then 3 parentheses x minus 1. If the question asked me to write the equation of the line in point slope form, I would use this, what I just wrote, as my answer. I would stop here. However, if it asked me to write the equation of the line in slope-intercept form, I need to keep going. Remember, slope-intercept form is y equals mx plus b. Compare these two. Y equals mx plus b doesn't have any parentheses, so I need to get rid of those first. Remember what parentheses mean is multiply, so I'm going to multiply what's attached to the parentheses, which is 3. So I'm going to have y plus 4, leave that alone, equals, getting rid of the parentheses, 3 times x is 3x, and then 3 times -1 is -3. Now compare the two equations. Y equals mx plus b. This is y plus 4 equals 3x minus 3. It's almost there, but I need y by itself. So right now y is being added with 4. So I need to undo the plus 4 and do the opposite, which would be minus 4. Now I'm going to minus 4 on my right side of my equal sign, but I need to do so underneath the number without the variable. These are like terms. This is not. So the plus 4 minus 4 cancels, and I'm left with y equals, and then I bring down the 3x, and then negative 3 minus 4 would give me negative 7. So this tells me right here, y equals mx plus b, the slope is 3, which that shouldn't change. But this, negative 7, tells me the y-intercept where this graph crosses the y-axis is at 0, negative 7. That is another point on the line, which is different from the original point that they gave me. All right, so if they asked for the equation in slope-intercept form, this would be my answer. Let's do another example. This next example, I'm given information about my line, but this time the given information is a graph. So I need to pick apart this graph and come up with my slope and an ordered pair. So slope, first thing I need to do is read my graph. So going from left to right, it's going down, which means my slope is negative. Next thing I need to do is my rise over run. So how many do I need to go to the level of my other point? Okay. Doesn't matter which one you start with and which one you go to. So I'm going to start with the lower one. I have to go up 2, so I'm at the same height as my other point. So it's going to be 2 over, how much do I go over? 1, 2, 3, 4, 5, 6. So that is negative 1 over 6 when I reduce that. So we try to write these where they're not in fractions, but I can't. This is a fraction. It's in simplified form, but it's at the end of the day, it's still a fraction. Next thing that I'm going to do is take a coordinate. So here are 2 nice coordinates that are on my line. I'm going to pick one of them. I don't need them both. So pick this one or pick this one. It's up to you. I'm going to do this one. So it has an ordered pair of 4, negative 4. So what I'm going to do is I'm going to plug these into my point slope form. So point slope form is y minus y1 equals, and then m, and then x minus x1. So I'm going to erase and replace certain values. So first one to erase and replace is m, the slope. So this slope is going to get replaced with negative 1/3. Then you erase and replace x1. So x1 is positive 4. And last, you're going to erase and replace y1, which is negative 4. All right, so once again, we have this minus and negative. So I'm going to change this to be y plus 4 equals negative 1/3, and then in parentheses, x minus 4. And we are all finished. If the question said to write the equation of the line in point slope form. If it asked you to write it in slope-intercept form is y equals mx plus b. We need to get rid of the parentheses, and then we need to get y by itself. So get rid of the parentheses by distributing. So this is going to give me negative 1/3 times x, which is negative 1/3 x. And this is going to give me negative 1/3 times negative 4. Feel free to use Desmos. And that's going to give me positive 4 over 3. Last, I need to get y by itself. I'm adding 4, so the opposite is minus 4. So I'm going to subtract 4 on both sides. This is going to give me y equals, and I still have negative 1/3 x. And now I combine these like terms, and I need to take 4/3 minus 4. Again, feel free to use Desmos. I don't think I can pull up Desmos with what I'm using right now, so I'm going to do the work off to the side. 4/3 minus 4 over 1. I need to have common denominators, so I'll multiply top and bottom by 3. And I'm going to have 4 minus 12, which is going to give me a negative 8 over 3. So this would be my final answer. Notice that my slope is still negative 1/3, but my y-intercept is at negative 8/3. So if I write that, that's what I was trying to do. If I write that as an ordered pair, this would be 0, negative 8/3. And negative 8 divided by 3 is negative 2 point something. Double check on the y-axis. Here's negative 2. Here's negative 3. Yeah, the graph goes in between negative 2 and negative 3 through the y-axis, which means that negative 8/3 is a plausible y-intercept. Let's do another example. This time, the given information. So the first time, it was just given to us in the sentence. Second time, it was given to us in a graph. Now we're going to practice if the table is giving us our information. So remember, your slope is your change of y's over change of x's. So we're going to start off with our y values, and we're going to figure out how much are we going up, how much are we going down by. So from 640 to 590, we're going down by 50. From 590 to 490, we're going down by 100. From 490 to 440, we're going down by 50. From 10 to 30, now we're looking at our change in x's. From 10 to 30, we are adding 20. From 30 to 70, we are adding 40. And from 70 to 90, we are adding 20. So you might be thinking, this is not a linear function because I don't have a constant rate of change. We're going by negative 50, then negative 100, then negative 50. And over here it's 20, then 40, then 20. And you're probably thinking, my teacher told me I have to have a constant rate of change. Okay. If you take a look at this, remember a slope, your rate of change is a comparison of your change in y's over your change of x's. So if I write this as negative 50 over positive 20. This next one, if I write it as negative 100 over negative 40, and then this one's negative 50 over 20, which I already have. Are these two the same? And you can use Desmos to see that we can simplify both of these down. Oh, that was positive 40. My mistake. So negative 50 over 20, and this is negative 100 over positive 40. Ask Desmos to simplify both those fractions for you. So the zeros cancel out here, and we're going to be left with negative 5 over 2. The zeros cancel out, and negative 10 over 4, both are divisible by 2, is going to give me negative 5 over 2. Okay, so you can't just look to see are they going up or down at a constant rate by themselves. What you have to do is write them as a fraction. So change of y values over change of x values. That's going to give us our slope. Next thing that we're going to do is get our coordinate. What is our ordered pair? We have 1, 2, 3, 4 ordered pairs that are given to us. Doesn't matter which one you use. I'm going to use the first one. The x coordinate is 10 and the y coordinate is 640. So point slope form, y minus y1 equals m parentheses x minus x1 close parentheses. Erase and replace m. Our slope m we said was negative 5 over 2. Erase, replace x1. x1 is positive 10. Erase, replace y1, which is 640. Okay. We have a single sign everywhere, so we don't even need to do that double negative change to positive. So if the equation asks you, or if the question asks you to write the equation in point slope form, here would be our final answer. If they ask you to put it in slope intercept form, which is y equals mx plus b, get rid of the parentheses and then get y by itself. So y minus 640 equals, we'll take negative 5 over 2 times x, which is negative 5 over 2 times x. So negative 5 over 2x. And then use Desmos, negative 5 over 2 times negative 10. And that's going to give me positive, let's see, 50 divided by 2, that's going to give me 25. Last thing, get y by itself. We're subtracting 640, so we'll add 640 to both sides. And we're going to get y equals negative 5 over 2x, and then plus 665. So there would be the equation of the line in slope-intercept form. The slope is still negative 5 over 2. This one tells me the ordered pair is at 10, 640. This one, the ordered pair is the y-intercept, and it's at 0, 665. All right, the next two, okay, take a little break from point-slope form. The next two are our special lines, which are vertical and horizontal lines. So remember, vertical lines, those are the lines that go straight up and down. Horizontal lines, think of the horizon. Those are the ones that go straight left to left. So it says graph the vertical and horizontal line that contains the point 5, negative 7. So first thing you'll need to do is put your pencil at the origin and then plot the point 5, negative 7. So 5 means to the right, 1, 2, 3, 4, 5. Negative 7 means down, 1, 2, 3, 4, 5, 6, 7. If I'm plotting a vertical line, that means I'm going to go straight up. Forgive me, that's kind of difficult, and straight down. So there's my vertical line. Now I need to write my equation of the line. Remember, these are special. This only goes through which axis? Which axis does it go through? Is it the x-axis or is it the y-axis? Well, here's the x-axis. It doesn't touch the y-axis. It's actually parallel to it. So that means it only goes through the x-axis. So our equation is x equals, and then the x-coordinate is 5. It only goes through the x-axis, so we only have x in our equation. And the slope of this, we're going up and down, but we don't go left or right any. So when you divide by 0, you can use Desmos, and it's going to tell you undefined. Versus a horizontal line, still plot the same point, 5, negative 7. The horizontal line goes left to right. So what is the only axis that goes through? And it's your y-axis. So it's going to be y equals, where does it go through the y-axis? That was at negative 7. And the slope of this line is it doesn't go up or down any, so it's 0 divided by any number, which is going to give you 0. All right, last example, we get back into point-slope form, and we are going to graph this equation. All right, so 2 ways to do this. First way is to put it into slope-intercept form, which we already know how to graph with. So solving for y. So get rid of the parentheses by distributing, and we're going to have y equals, or sorry, I forgot my minus 5. We're going to have y minus 5 equals, and then negative 2 times x is negative 2x, and then negative 2 times positive 3 is negative 6. Okay, so now we have the parentheses gone. The equation, slope-intercept form, y equals mx plus b. We need to have y by itself. So undo a minus 5, which means add 5. It doesn't look like this, but it looks like this. So we'll add 5 to the minus 6. These cancel. This will give me y equals, and then negative 2x, and then negative 6 plus 5 is negative 1. So here's my slope-intercept form, which tells me, okay, when I compare these, my m, the number in front of x, is negative 2. Since I'm graphing, I'm going to write that as over 1. This tells me to go down 2, and my 1 tells me to go right 1. The y-intercept is what's after x, which is negative 1. So my b is negative 1, which if I write that as an ordered pair, it's 0, negative 1. So on the y-axis, I find negative 1, and I plot a point. And from there, I move negative 2 over 1. So down 2 to the right 1, down 2 to the right 1, and I can continue this. Or the opposite way is up 2 to the left 1, up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. And then the best that you can, connect them. All right, and that is how we are going to graph a line in point-slope form, is we're actually going to put it into slope-intercept form. For those of you that are interested, technically there is one more way that you could do this. And remember that your point-slope form is y minus 5 equals -2 and then x plus 3. The formula is y minus y1 equals -2 x minus x1. Not -2, I'm so sorry. Y minus y1 equals m, and then in parentheses, x minus x1. So what this tells us is what's in the spot for m is the number -2. So the slope is -2, which we already said over here, -2/1. The difference is this one doesn't use a b. Instead, we identify what is x1 and we identify what is y1. So the number in the spot for x1 is a 3, but since the sign changed, it means that we're going to use a -3. And the number in the spot for y1, and it has the correct sign, is a +5. So double check, is the ordered pair -3, +5 graphed? And -3, +5 is on our line. So had we done it this way, we would have started with this point at -3, +5, and then we would have moved down 2 to the right 1, and it's just another way that you can graph. You don't have to use both methods. Choose which one you like better. Honestly, I think I would solve for y and put it in slope-intercept form in order to graph. I think that's probably going to be the easier way. But for some of you, I know you like a challenge, so feel free to use point-slope form and get your point, and then use that, plot it, and then use your slope to move. And there you have it, point-slope form.